Hi, and welcome to lessons 4.4 and 4.5 for Honors Geometry. So today we're going to learn more about how to prove triangles congruent to each other. So let's just go ahead and jump right into it. Okay, we have another postulate. Postulate 20 is our side-angle-side congruence postulate. And again, remember, postulates are things that we can use in theorems to prove our theorems, but we don't actually prove the postulates ourselves. So this postulate says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, there's a lot of words in there. Let's figure out what they're talking about. First, we know that we have two triangles. And we start out by saying two sides are congruent. So let's go ahead and mark two sides of these triangles to see what they're talking about. So there's one side of each triangle congruent to each other. And now we have this blue line showing another side. So we have our two sides congruent to each other of two triangles. Now we see this part right here, the included angle. This is a specific angle. It is the angle made by these two sides right here. So it is going to be the angle that is created from those two sides. So let's go ahead and mark that. So this now shows us our side, angle, side congruence. We have side, the angle in between the two sides, and our other side are congruent to each other. Side, angle, side. So that is our side, angle, side congruence postulate. Okay, let's move on. So we're going to use the side, angle, side congruence postulate to prove that the two triangles in this diagram are congruent to each other. So first, we are given that BC is congruent to segment DA and segment BC is parallel to segment AD. Okay, let's go ahead and start this proof. First, we've got to write down our givens. So there we go. Now let's go ahead and mark our diagrams. Okay, so we now have BC congruent to AD with the hash marks, and we've marked BC parallel to AD. So we've marked everything that we've got. Next, taking a look at this, we have a couple of different ways that we can go. So the next thing that I see is I know I want side, angle, side. I got to figure out what other side I can prove is congruent to the other side of the triangle. And I see right here, side AC is shared by both triangles. So from my reflexive property, I can say that segment AC is congruent to itself. Okay, let's go ahead and mark that now. All right, the other thing that I have is I have two parallel lines and this transversal that crosses those parallel lines. So remember back from chapter 3, we know with a transversal and parallel lines, there are many different types of angles that are congruent together. Well, I'm going to be looking at interior angles since everything's in between these, and specifically alternate interior angles. Now remember, I'm wanting to prove it through side, angle, side. So BC and AC are my two sides. So the angle made between them is angle BCA. And that we know is congruent to angle DAC. These are alternate interior angles. We can prove that through our alternate interior angles theorem. So angle BCA is congruent to angle DAC. Okay, so now we have side, angle, side congruent to side, angle, side of the two triangles. We have now shown the triangle ABC is congruent to triangle CDA. Okay, let's move on. Now we have another example. We've got this circle with two triangles in there. All we are told is C is the center. So can we say the triangle SCR and triangle QCP are congruent? Well, yep, we can. So let's go about and figure out how we know this. If C is our center, we know that any segment that goes from C to the edge of the center is a radius, and they are all congruent. So we actually have a lot of congruent segments here, and we're going to go ahead and mark those. So we have many different segments that are congruent to each other. We don't know anything about SR or PQ, but we also have a pair of vertical angles. That would be angle SCR is vertical angle to PCQ. So let's mark those. So now we can see that we have side, angle, side of one triangle congruent to side, angle, side of another triangle. So yes, they are congruent from our side, angle, side postulate. So you're going to have to apply knowledge here when you have these types of proofs. You're going to have to think outside of the box a little bit. Okay, let's move on to the next slide. So now we have a theorem. This is our hypotenuse-leg congruence theorem. And this specifically is pertaining to a right triangle. So you have to keep that in mind with regards to this theorem. This only applies to right triangles. And it states, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second triangle, then those two triangles are congruent. So remember, if we have a right triangle, excuse my drawing there, here's our hypotenuse and here's one of our legs. We'll call it leg 1. So what this is saying is that if we have a right triangle and our hypotenuse and leg of one triangle are congruent to our hypotenuse and our leg of a second triangle, so this is congruent and these are congruent, we can state that these two triangles are in fact congruent to each other. So that is your hypotenuse leg theorem, and it's only for a right triangle. Okay, let's move on. So now we're going to determine whether or not we have some congruent triangles. And I gave you a hint that we're going to use our side, angle, side postulate. Okay, so here we've got a right triangle. So you might want to think about the hypotenuse leg triangle, but we don't have any information about our hypotenuse leg. So we're going to take our hypotenuse here. We just have information about the legs. So if we take a look, we have one side congruent to one side. So we've got a side. Do we have an included angle? Well, we've got another side right here. So this is our other side. And we do have the angle in between them. They both happen to be right angles. So yes, they are marked as congruent. So yes, these two triangles are congruent. Okay, let's move down to this example. Okay, only thing that we've got right now are these two sides being congruent. So we know we have a side. We know this side is congruent to itself. So here's another side, and we'll mark that. Okay, so we've got parallel lines. So we've got an angle right here. So remember, you're going to want to look at the angles between the two sides if you're talking about side, angle, side. So side, side, and this angle. Can we say that those angles are congruent? Well, we've got parallel lines and a transversal, and we know alternate interior angles are congruent. So yes, we have side, angle, side. So we can prove that these are congruent as well. All right, we're almost done. We have a couple more postulates and theorems, and then we're going to move on to one last type of proof, and it's a new kind of proof. So postulate 21 states our angle-side angle congruence. So this says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then those two triangles are congruent. Okay, so that's meaning that let's say we have two triangles here. We have two angles that are congruent to each other on both triangles. So we've got one angle marked, and let's say we have this angle right here marked. So there are our two angles. And then we got that included word again, that included side. So that means the side in between the two angles. So for example, if this side right here is congruent to this side right here, then we know these two triangles are congruent by our angle, side, angle postulate. We go angle, side, angle, congruent to angle, side, angle. Now we have another theorem, angle, angle, side. And it's just what you're probably already thinking. We're going to have two angles in a row and then a side. If you notice, here we had angle, side, angle. That's how it was laid out. Now it's angle, angle, side. So it says if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then those two triangles are congruent. Okay, so let's quickly draw this one out as well. Okay, so we have two angles. So there's one angle. And let's change pen colors. Here's another angle. And we want the non-included or a non-included side. So we don't want the side in between them. We want one that's not included. So if we have this one marked, notice how it says the corresponding non-included side. That means that this side would also have to be marked. We couldn't have this one over here because that's not corresponding to the angle that it was congruent to. So this gives us angle, because we have an angle right there, and then angle again, side. So angle, angle, side. And we can know that those triangles are congruent. Okay, so now we're actually going to prove the angle, angle, side congruence theorem. So we are given the following diagram, and the markings on them are marked as congruent. So we see that we've got side BC is congruent to side EF, angle C is congruent to angle F, and angle A is congruent to angle D. So first we're going to start out with the two angles. So angle A is congruent to angle D, that's marked in the diagram, so it's a given. Angle C is congruent to angle F, again that's marked in the diagram. We learned from our previous lesson, from our third angles theorem, that angle B is congruent to angle E. Okay, so this proof is not looking like what you're used to. It's not a two-column proof. This is what's called a flow proof. So sometimes you can use these proofs as well. You can always use a two-column proof. But this is kind of more like a flow chart where we're going to show different things here. So we know from our two angles of two triangles being congruent that that third angle has to be congruent. Okay, so let's mark it. So we now have angle B is congruent to angle E. Okay, so we still have a given that we haven't used, so let's go ahead and state that. BC is congruent to EF. Okay, so we have lots going on here, but let's take a look at this diagram. We know the angle B and angle E are congruent. We also know that BC and EF are congruent, and angle C and angle F are congruent. So if we take a look, this would be an angle that we have congruent over here, a side that we have congruent over here, and another angle. So we know that we already have congruent triangles because this is our angle, side, angle, postulate. And remember, we don't have to prove the postulate. We can use that in our proof here. So from those three things, we can now say that triangle ABC is congruent to triangle DEF through our angle, side, angle postulate. And we have now proven that if we are given angle, angle, sides of triangles, then that in fact is proof enough that those two triangles are congruent to each other. So that is your first flowchart proof. Okay, now we're just going to recap. So these are all the ways to prove that triangles are congruent. Side, side, side. We didn't learn that one today. We learned that one previously, but all three sides are congruent. Then we have our side, angle, side. That was our first postulate today. Then we learned about right triangles, and they have a special one that we can sometimes use called the hypotenuse leg. And then we had the angle, side, angle postulate, and the angle, angle, side theorem that we were able to prove using our angle, side, angle postulate. I know that's a lot of information. I hope you guys enjoyed this though, and look forward to seeing you soon. Take care. Bye-bye.